So for this problem, this is problem 1360. The text that comes with it says at the instant theta equals 60 degrees, the boy's center of mass g has a downward speed v sub g equal to 15 feet per second. Determine the rate of increase in his speed and the tension in each of the two supporting cords of the swing at this instant. The body has a weight, or the boy has a weight of 60 pounds. 60 pounds. Neglect his size and the mass of the seat and cords. So for the solution, we're going to start just like before. We always did free body diagrams. Just now we have to add that kinetic diagram. So for the free body diagram, I'm just going to draw the boy. Not the best drawing, but it'll be fine. And draw all of the forces that we have. So we have his center of gravity, and we have his weight, which is 60 pounds. He's on this swing, so he's going to have sort of a, or let me pick a different color for that. So it makes sense to do normal and tangential directions. So we're going to have 2T, because we have two cables, and so we'll just call them, each of the forces is T, but it'll be 2 times T because it's 2 cables, because it's a swing, or 2 ropes. And I think that'll be all the forces we have. We do know the angle. So the angle here is 60 degrees. Also this angle here is 60 degrees. And then we need to draw that, or do that equal to the kinetic diagram. And for the kinetic diagram, so we still have that G. And then because we have normal and tangential acceleration, we have ma sub t and ma sub n. So you have a normal, or you have acceleration that's sort of the rate of change that's tangential to the curve that you're on, so that's that ma sub t, and then the ma sub n is in that normal direction, so towards the center of the circle or whatever. So with this, we get, we know his velocity, his tangential velocity is 15 feet per second. So we can sum the forces in the tangential direction equals mat, and the forces in the tangential direction is the 2t is actually in the normal direction. The weight has some component, so the weight would be 60 cosine 60 degrees, and that's pounds, and the positive t, and that equals the mass, which would be, so we know weight equals mass times acceleration. So mass is going to equal weight divided by g, and the weight was 60 pounds divided by 32.2 feet per second squared, and that's just the acceleration due to gravity in feet and seconds, times a sub t. And so now we can solve for a sub t. Calculator. We get a sub t equals 16.1. And it will be the pounds divided by pounds over feet per second squared. So these cancel out. That gives us 16.1 feet per second squared. So that's the tangential acceleration, which was part of what we were supposed to find. And then, let's see. And the tangential acceleration is the rate of increase in a speed. And then we also were supposed to find the tension, and so that's in the n direction. So let's sum the forces in the n direction equals, and I'm just looking at the left side and then the right side of our diagrams, equals M-A-N. The forces in the n direction, we have 2 times T minus 60 pounds sine of 60 degrees, and that equals that mass, which was that 60 pounds divided by 32.2 feet per second squared, times that normal acceleration. And normal acceleration, if we remember, a sub n equals v squared over rho. So the v squared, the velocity was 15 feet per second, and that's squared divided by rho, and they did give us the length of the cable was 10 feet. So then we can solve for this, and let's see what we get. We get T equals 46.9. Let's see what the units do. So feet squared per second squared. So that would be feet per second squared over here, which would cancel out with that one. So then we get pounds. So it's just pounds, which is correct. So we get T equals 46.9 pounds. So we found A sub T and T.